Alright, welcome back. So, we are up to the Swapchain. Last time we got our Windows surface ready and we added the rendering queue, I think it was. So good look. Or the querying thing. Presentation queue, that was the one. There we go, we got that ready. So now we're on to the Swapchain, which is, I think, how we send commands to those queues to do stuff. And hopefully we can get to actually render something pretty soon. Let me just bump that up a bit. Alright. So, Vulkan does not have the concept of default frame buffer, hence it requires an infrastructure that will own the buffers. Okay, so this is the series of buffers that help you do synchronization. So you don't get any half-rendered stuff appearing on the screen. And blah, 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 blah. The infrastructure is known as the Swapchain and must be created explicitly in Vulkan. The Swapchain is essentially a queue of images that are waiting to be presented to the screen. Our application will acquire such an image to draw to it and then return it to the queue. Okay, so it like recycles those frame buffers. How exactly the queue works and the conditions for presenting an image from the queue depend on how the Swapchain is set up, but generally, the purpose of the Swapchain is to synchronize the presentation of images with the refresh rate of the screen. Alright, that sounds fine. Checking for Swapchain support. Not all graphics cards are created equal, are capable of presenting images directly to the screen for various reasons. For example, because they are designed for servers and don't have a display outputs. Right, like crypto mining. Okay, secondly, since image presentation is heavily tied to the Windows system and the surface associated with the Windows, it's not actually part of the Vulkan core. Okay. You have to enable VKKHR Swapchain device extension for querying for the support. Alright, sounds good. For that purpose, we will first extend the is device suitable function, which we don't really have. We were just using our rate function to do a lot of these queries, so probably stick it in there, I guess. We've previously seen how to list extensions and how to use them. Yep, that's fine with the VK physical device. So doing that would be fairly straightforward. Note that the Vulkan header file provides a macro called VKKHR Swapchain extension name. Let's copy that. It is defined as or expands to VKKHR Swapchain. The advantage of using this, spelling errors here, great. First, declare a list of required device extensions similar to the list of validation layers. Alright. So we did that originally up the top here, so let's just do the same kind of thing, I suppose. This is going to be Swapchain. Oh wait, no, device extension, sorry. Device extension count, probably. We'll probably need the count as well. Let's go device extensions. And is it going to be the same data structure? A vector containing const jars? Yes, I believe it is. And I think we just put that in. Cool. Next, create a new function, check device extension support. That is called from within is device suitable. Now, it's going to be called on each device, and it's probably going to be something that affects the score that we give the device. So let's go to our rate device suitability function. Oh, it's also worth noting that I realized I didn't have Emacs's fly check enabled, so I did. So we've got a bunch of these little errors which we'll sort out in a bit. Rate device suitability, there's the function call. Where would we do it? So here's where we do the geometry shader check, since return 0 if it doesn't have a support. And here we do our queue families. Let's do it below this, I suppose. So we're going to call this function, pass in likely our device, maybe some other stuff. And then let's define this function just a little bit further up here. It returns a bool. Is device suitable? Returns boolean of extensions supported. Okay. So a bool of extensions supported. All right. And then it does its usual check for the indices being complete. And it looks like if device extensions aren't supported, we're kind of saying it's not a suitable device, so we may as well do something similar. So if extensions aren't supported, should we just return 0? Probably. We've probably returned 0 here too. That makes sense. Okay, cool. Let's do the same kind of deal as well, where we want to output and say no support. And device extensions not supported. Let's call it required as well, because there's likely going to be a few that we need to check for. All right, now the body of the function. Modify the body of the function. Blah, blah, blah. So we enumerate the extensions and check if all the required extensions are amongst them. And I think we've only got one required extension so far. But okay. In the body of the function, we do indeed take our VK physical device. So let's go up here and return a bool, passing that, and VK physical device. And there's that device. And we want to do a U32 of extension count. VK enumerate device extension properties. Enumerate device extension properties. Passing in our device some sort of null pointer, the address of the extension count, and null, I think it was. Yep, because then we create our available extensions array and then pass that to the second call of this function. Same thing we've seen a bunch of other times. Okay, so it's going to be of this type. Let's copy that. And let's call it, let's call it the same thing. Available extensions. And the size is going to be the extension count. Cool. And then it looks like we passed that to there. Yep, that all looks good, I think. Oops, sorry. And then what happens then? Then we'll do our looping. Yep, so what are they doing here? Creating a set of the required extensions, going through all device extensions. What's device extensions? That's these things. Okay, well you're declaring it. We're declaring it ourselves, and then we're creating a set of them. Weird. Like the set would make sure that everything in there is unique, but we're already making it ourselves, so we kind of know that. All right, carrying on. Then we loop through those available and see if it exists in the required. We've done something similar to this before. Where did we do that? When we went through let's just find the validation layers. Where's the loop? Here it is. So we went through all the validation layers and we checked to see if amongst the available layers, the validation layer existed. And then we did this cool thing where we had the locally bound layer found or layer exists, false. And then if it was found, we set it to true, and then we checked if it was false, we would just return and say, there's no support for this thing. So let's do the same kind of thing. So for int I, equal to 0. And the count we care about is not this extension count. We care about this top one, yeah, the device extension count. Okay, so, sorry, I is less than that, and then I plus plus. And we're getting a little error here because, what does it say? Comparison of integer expression of different signed. Oh, okay, so int is assigned, it could be a negative or not. So we could probably switch this to a U32. In fact, we could probably switch it to like a U8, but that's fine. Okay, that checks out, that works. We also want to return false by default. Or do we? No, it's probably true because we'll bail early if we have no support for one of these. All right, so go through our extension count. If device extensions at position I, because we're looping through those. Oh, we have to double. Oops. Excuse me. We have to double loop, don't we? Yeah, okay, so let's switch this to J. Because every time we go through the required devices, we then need to loop through this available. Maybe we should loop the other way around. Perhaps. Okay. This time we're looping through here and we're doing J++. And we are checking. We'll do a local scope to say bool extension found equal to false. Then here will be where we do if extension not found, then return false. So we bail early. That can make sense. So now we do our string comparison, strcmp, where we want to find out if it equals 0. We know it's a match. So the first one is this device extension, which I think is a struct. Oh, our second loop is J. No, that's the wrong one. So that one's not a struct, that's just a regular string. But the available extensions at position J, I think is a struct. So let's take a look at this. Did they have a link to it somewhere? No. That would have been nice. Let's open this. I'm gonna have to look through all of these, I suppose. Show me this thing. This has a property of extension name, which is the string we care about. Okay. So, oh man, this will be dot extension name. And we're not getting any errors from fly check, so things might be all right. And here will be where we say, okay, it's found. It's true. Right, and then break, because we don't need to continue that loop. Now, is this more efficient than looping through the available extensions first? It's less efficient, I think, because there's more available extensions. Perhaps that should be the top level one. But then we would have to loop through the whole thing anyway. It's probably like not that big a deal. We're not going to be pulling huge amounts of extensions, I wouldn't think. All right, great. Let us check. Actually, let's do some logging. Good old logging. And say what we're checking for. Yeah. Printf. Checking if this thing equals this string. And this is the first thing we're passing in, and this is the second thing we're passing in. Okay. So then we can see when we're logging that out, we can see if we're actually doing the correct kind of comparison. And we are calling that function, so let's just test and compile it. Checksums. Build and game. Oh, I'm in the wrong directory. I'm in the wrong window. Looking at Linux. Building game. Okay, so looks like we're checking for the right kind of stuff. We're only caring about Swapchain. We went through all of these before we found the Swapchain. Oh, but then we continued. Why did we continue? Huh. Went through all of our one device counts. And we didn't seem to break. Let's see if the extension was actually found. Okay. Printf. Extension S found. And it's this one because this is the device we're checking for. I mean the device extension we're checking for. Oh, you can't Swapchain. Where is the other Swapchain? So we went through all of these devices before we found the Swapchain. And we said extension Swapchain found. And then we did it again. Oh, one for each GPU device. One for each physical device that we're trying to find. That explains it. Okay. So no need to do that. That all works pretty nicely. Cool. So we did that, and then we now need to. So I've chosen to set the string to blah 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 blah. You can of course use nested loop like this one. The performance difference is irrelevant. Okay, so using a set was just kind of like code golf, kind of fair enough. Enabling the device extension. Using a Swapchain requires enabling the VK blah 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 extension first. Enabling the extension just requires a small change to the logical device creation structure. Awesome. All right, let's add that in. Make sure that you replace existing. Yeah, we did have this existing line. Oh, that definitely exists. Hey. Maybe we didn't call that. Ah, we didn't. We would have done this. So there it is. So is this for our, yeah, this is our device create info, and this creates our physical device because we are setting it here. All right, one. Maybe you have to come back to looking at this. All right, so let's set this to 1. Oh no, let's just do the variable instead of magic numbers. What's it called? Device extensions. Device extension count. And we also need to do the PP enabled extension names. And that is our extensions. But likely a pointer to it? No, it already is a pointer. Where else is that being used? Not in this function, at least. It's in the instance. Yeah, creating the instance. Same kind of thing. Those are instance related, like window related. Okay, so I think that should enable these extensions. Let's do another one of these. Why did I even do that? Weird. No major errors? It's good news. So perhaps we've enabled it. That would be just grand. Okay. Then we'll move on to querying details of Swapchain support. I'm going to leave that for the next video because this might get too long. All right, thanks for, wow, yeah, I will git status, git add main, and readme, because I think I made some quick updates to that. And don't do that. Git commit, enabled Swapchain, cool. Git push, origin and main. And there we have it, all good. Thanks for watching. See you in the next one.